Hello and welcome to another video. In this video we're going to be continuing on with the TypeScript and we're going to be doing unique paths. So in this problem you have a robot on an m by n grid, so this is m, this is n, and you're trying to get to the end and you want to figure out how many total paths are there that get to the end. So these values are relatively small, I think they're up to like 100. Pretty much you're trying to find the number of total paths. So as you can see in this first example, there's a ton. But pretty much this problem boils down to a couple of things, right? So we're going to go through the quick solution, and it's going to be a DP problem. It's one of the easier DP problems, but let's just go through a quick solution for this, for like our DP. So DP needs three things. It needs a base case, needs a recursive case, and then it needs some kind of state variables, right, that we need to store. So let's start with the state variables. This one's pretty straightforward, right? We're going to have a row and we're going to have a column. Pretty straightforward, like what else would you want? Okay, what about the base case? So the base case is we're at the finish. So if we are at finish, let us return 1 because we made it, right? And then there's another base case. If we are out of bounds, let's return 0, right? Like let's say we go down too far or we go right too far or something. You can also keep track, like you can just make sure that you can never go down and out of bounds, and that would be totally fine. And then what's the actual recursive case? And that's the kind of tricky part of this problem. Well, at every single path you have two choices, right? You can either go right or you can go down, and either one of those is valid. It's like climbing stairs if you could jump 1 or 2 stairs. So essentially the recursive case here is you can go down or right, and we have to add the paths for both. Right, so you would just say, okay, let's try to go down, let's try to go right, let's add both of those, and then obviously for another base case we're gonna have a cache, right? Because we can get to the same place twice. How do we do that? Like let's say we get to this location, right? Well, how do we get to this location multiple times? This is one path, but this is also another path, right? Also, this is a path, and so on. So you want to be caching your inputs because it doesn't matter how you got here. The number of paths from here to the end is going to be the same regardless of how you got here, right? If you got here this way, the number of paths is going to be the same. If you got here this way, it's going to be the same. It doesn't really matter. So that's pretty much going to be the solution, is essentially we are looping, or not looping, we are doing a dynamic programming problem with a cache. And I will show you some cool stuff that you can do. So usually you use an object cache, but we're going to use an array cache, and I'll kind of show you that in the code as we go. But that's pretty much actually it for this problem. Like you literally just go down and right, and you add those together. And then your base case is you're at the end, or you have some kind of cached output. So pretty straightforward problem. Now let's actually code it up. And here we go, and we're just going to code straight in here. So first what we're going to do, normally we use an object, but instead of making an object, we're just going to make an array of the same length as this array. And we're just going to fill it with -1s. And so the way to do that is we can say, like, because we could use an object, but, you know, then we'd have to have keys, and then we'd have to, like, stringify the keys, and we're just going to use an array instead. And so I haven't done this too often, but I'll kind of show you how you make an array for a visited instead of an object. And it's going to be the same space complexity. So what we need to do is we're going to make an array of length m, and we're going to fill that with null. So that's going to be the rows. But now what we want to do is for every single row, we actually want to put in n columns. So the way to do that is you do a map, and then you just give it a function here. That's going to take in nothing, and it's going to return a new array of length n, and now we're going to fill that with -1. Because we want initially to have an array of length of this array, but we want to fill it with -1, meaning -1 means we haven't visited yet. And so we can actually console log this, just to show what happens here, visited, and then we're actually going to return something just so it doesn't like complain. So if we look, so here's our array. So you can see like row 1 has 7 -1s, row 2 has 7 -1s, and then row 3 has 7 -1s. But yeah, pretty much you're just making, what you're doing here is you're saying, okay, let's just make an array of 3 elements. Let's fill those all with null. You do have to fill before you map, otherwise it complains. And then you say, okay, for this null value, for every single value here, instead of getting null, like forget that, let's just map this with and length -1. So this would be 7 -1s. Then it would map that and so on. So that's how you make. That's one way to make a 2D array. There's a bunch. You can obviously use like a nested for loop where you just make an array of length 3 and then you just keep adding numbers. Like there's a bunch of ways you could do it, but this is a one-liner to do it. Okay, so now we're going to use this visited, and now this is going to be essentially our visited set, as I use in most problems, except we're going to use a visited array. And I did see some other people do things like this, so I just wanted to try it, and I think it makes sense. It's it's a little bit different, but yeah. So essentially, you just make an array, you make it length of all the possible states, and you set it equal to some value, and then you say like, you obviously want to set it equal to some value that a valid answer can never be, and then you can just check like, if it's -1, that means we haven't visited it. Otherwise, let's just take that value. Okay, so now let's go through the rest of this. So now we're going to make our DP function. So we'll just use function. Actually, we'll just use const, right? I think I prefer const. So it's going to be a function. It's going to take in a row. That's a number. It's going to take in a call. That's a number. And it's going to return a number. Okay, and the function is going to be like this. I think we might actually need to do this, I believe, but we'll go back to that. I'm not entirely sure. I also can't see like this actual problem, right? So, but I think this is actually the format you would want. Okay, so yeah, let's go through the actual DP part and then we'll worry about fixing this part over here. So essentially, let's go through a base case. So if our row is m-1 and our column is n-1, that means we're at this finish thing, right? Because this here, m is 3 and it's 7, so we're going to want to be at 2 and 6, and that means it's the finish line. Okay, so we're just going to return here 1. Okay, now let's look at, so yeah, that was fine. Okay, so now let's say if the row, let's check for the out of bounds case, because I'm not going to be checking for like making sure numbers don't go out of bounds, so I'll just handle that in my base case. So in this base case, if the row is too big or if the column is too big, let's return 0 because we're out of bounds, so that's not valid. Now finally, let's check, or not finally, but let's check one more. So if visited row column does not equal -1, that means we have it already stored, so let's just return that. Row column. And yeah, it just makes it a little bit easier because then we don't have to like stringify, because now we're going to have like a tuple or something as a key, and you can do that, but in order to stringify, or I think you have to use a map, but I think an array is a little bit easier when you have to use like 2 or 3 values as the key. Okay, and then now we're going to actually get this value, so we're going to say visited row column, and remember we can either go right or we can go left, so let's calculate both of those. So one is going to be row plus 1 call, and the other one is going to be row call plus 1, right? Both choices. Finally, we can return it. Row call. There we go. And let's return dp of 0, 0 because we want to start at the initial index. So let's see here. But yeah, this is one of the simpler DPs, and I just wanted to show this like one-liner for the fill. And then the rest of it, TypeScript-wise, is pretty straightforward. Like, yeah, you want to give your types here, but like I said, I usually prefer not giving types to anything that's redundant, right? So I guess here we don't have anything redundant, but if I had some value, like I don't give it types. Some people do prefer giving it types, but if I had something like, or even let number, not number, I guess, num equals like 5, I wouldn't give it a type here. So I guess there's not too much TypeScript for this particular problem. And the DP is pretty straightforward. And I'm not going to go into the space optimized bottom up. I will link it if you want to see like the optimal solution and more in depth of like this actual solution where I literally spend like 30 minutes showing you the optimal solution. So if that's what you want, I can link that one. But if you're just here for the TypeScript, then this is going to be good enough for us. Okay. And so you can see our code is reasonably efficient, like I said, for the TypeScript. It definitely is inconsistent, like it runs all over the place, so I wouldn't pay too much attention to this. It's a reasonable solution, we have TypeScript, so that's kind of all we're trying to get out of this. Okay, and yeah, that's going to be it for this video. Oh, I forgot one more thing, so let's actually go through time and space. So for the time, this is row times column, right? Like we are going through the whole matrix. And once you get this value once, then you're not like you're calculating O of 1 time. So worst case scenario, we have to get every single one of these, and that's going to be row times column, right? So assuming this is O of 1 time after the first time calculating it, then you just have 3 or 4 operations per dp, which is constant time. And yeah. And for the space, we did make this array of row times columns as well. So that's going to be that. Yeah, that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.